All right, so number 6, it says, base your answers to the following questions on the passage and photograph below on your knowledge of earth science. A photograph shows an orthositic, nice bedrock from Whiteface Mountain in New York. All right, so once again, one of the things that I like to do is I like to go right to the question first, just to read the question to see, okay, hey, can I answer this just based off the knowledge of earth science, right? The reading does help. So, and then whenever that you're stuck, you can't answer it directly from your own knowledge. The reading can help provide some information. So it says the texture of the gneiss indicated that the bedrock went through what? All right. So first of all, gneiss is what type of rock? What is gneiss? What type of rock? So when I'm looking through page 6, I don't see gneiss. I'm looking through page 7, sedimentary rocks, I don't see gneiss. When I look through the metamorphic section, I see gneiss, right? And what's very interesting about page 7 gives you a lot of information about the rock. It can tell you how it's formed. It can tell you what's in it. It can tell you the crystal size. It can tell you even the texture, right? And so when I look at the question, it says the texture of this gneiss indicates that the bedrock is what? The bedrock is blank. When I take a look, first of all, the fact that I see that this is a metamorphic rock, right? The fact that I know that it's a metamorphic rock, I already see, before we even get to bioclastic origin, before we get to any of that stuff, I'm going to look at page 7 and I'm going to see how exactly gneiss was formed. When I take a look at gneiss, how it was formed, what type of metamorphism, look right here. Look what it says. All of these rocks went through regional metamorphism. And the difference between regional and contact is when a metamorphic rock is made primarily due to heat, and regional metamorphism is when the metamorphic rock was created mostly due to pressure. And so therefore it's a regional metamorphism that created gneiss, regional. So therefore I look at my choice and I see the same thing, regional, right here. And so my correct answer is going to be choice B, underwent regional metamorphism. Gneiss, right here, goes through regional metamorphism, right here, regional metamorphism. All right. Number 7. So it says the two photographs below and the arrow between them show conglomerate and the process that changed from conglomerate to rock X. All right. And it says to rock X. Rock X is most likely what? All right. So I know the original rock was conglomerate, right? The original rock was conglomerate. One of the things that I see is the fact that the two photographs below in the arrow show conglomerate. The process changes to conglomerate at rocks X. Heat and pressure was added to it, and it looks like the pebbles are stretched out, right? Doesn't it look like it's kind of stretched out? So therefore, the metamorphic rock that shows that the pebbles, right, and the rocks and other fragments can be stretched out is metaconglomerate. Right here. Right here it says pebbles may be distorted or stretched. So therefore, metaconglomerate is the correct answer. And that's why it's choice C. All right. Number 8. It says, base the answer to the following question on the photograph and cross-section below and on your knowledge of earth science. The sequence of rock types found in the walls of the Grand Canyon are shown. The names of rock formations are shown, and the upper and lower boundaries of each formation are indicated by dashed lines. The rock layers have not been overturned. Now it says, if Vishnu schist have been exposed to greater heat and pressure during metamorphism, it could have formed what? So the question is asking, what if schist, Vishnu schist, what if it was exposed to even greater heat and pressure? So I'm going to look where schist is right now. And I see right here, schist. And the question says, well, what happens if schist was exposed to even greater either greater heat and pressure? Well, when I look at the type of metamorphism right here, it tells me that as I continue to go down, right, from slate to phyllite, from slate to phyllite to schist to gneiss, the heat and pressure increases as it's going down. So if I want a rock that even goes through even more heat and pressure, I have to go one step lower. And therefore, my answer is going to be gneiss. So remember, only for foliated rocks, for this section alone, when you're going down from slate to phyllite to schist and to gneiss, the type of metamorphism, it increases as you go down. And so that's why the correct answer is gneiss, choice A. Okay? Number 9, 3 more questions left. So bear with me. And remember, you can pause, you can rewind, that you have the freedom to do that with the video. All right? Number 9, it says, base the answer to the following questions on the diagram below of 5 rock samples. It says, if granite was subjected to intense heat and pressure, it would most likely change to what? If granite, so I'm taking a look to granite, right? If granite was subjected to more heat and pressure, it will most likely change to what? So automatically, I know that if it goes through heat and pressure, it has to be a metamorphic rock. If it goes through intense heat or pressure, my answer has to be a metamorphic rock. All right? So automatically, I'm going to find out which rock is a metamorphic rock. Is conglomerate a metamorphic rock? Let's see. When I look, I see conglomerate right here. Conglomerate. Conglomerate is a sedimentary rock. All right, let's see what else. Is sandstone a metamorphic rock? Sandstone, I see sandstone right here. Sandstone is also a sedimentary rock. Remember, if it goes through intense heat or pressure, it has to be a metamorphic. Basalt. Where do I see the word basalt? It's not here. It's not in page 7. Basalt, basalt. Where do I see you? Where do I see you? Basalt. I see you right here. Basalt is an igneous rock. So the only rock that goes through intense heat or pressure is gneiss. So this is a process of elimination. The only rock that goes through intense heat or pressure, right, would change to gneiss is a metamorphic rock. Boom. All right. So therefore, gneiss is a metamorphic rock. And what do I know about metamorphic rocks? According to my rock cycle, right here, metamorphic rocks, they always go through intense heat and or pressure. That's why the arrows are pointing to metamorphic rock. And so that's why the answer is choice C for number 9. All right. Number 10. We're looking at number 10 now. Oh, there you go. Number 10, the diagram below shows the igneous rock intrusion in sedimentary rock layers, right? At which point would metamorphic rock most likely be found? Remember, contact metamorphism is always going to be found in between the igneous rock intrusion and where the sedimentary rock is. If we go back to what we learned about contact metamorphism, right? You have hot magma, the rest could be sedimentary rock. Contact metamorphism happens in between the magma and the sedimentary rock, right here, right? Metamorphic rocks are formed right between magma, where this is where igneous rock would be, and the sedimentary rocks in between. So the only letter that shows in between the igneous intrusion and the sedimentary rock is choice B. It has to be in between the borderline where the igneous intrusion is and where the sedimentary rock is. That's where contact metamorphism occurs. That's why it's choice B. And last, number 11, I'm sorry. The diagram below represents a rock with distorted layer structure. In our notes, the distorted structure of this rock is most likely a result of what? In our notes, there's only one type of rock. There's two ways that we can identify a metamorphic rock. If we see banding, right, foliation, if we see banding, which banding means you see the lining of minerals, or if you see distorted wavy patterns. So we know that this rock is a metamorphic rock. Metamorphic rocks go through what? If you ever forget, what do metamorphic rocks go through? It's the rock cycle on page 6. I'm seeing metamorphic rock and I'm looking at the processes that point to metamorphic rock. And it says right here, it goes through heat and or pressure. Heat and or pressure. Where do I see heat and or pressure? Boom. Choice D. All right. So we know this is a metamorphic rock because of its distorted wavy structure. And that's all it is. Well, how do I turn the meeting? Sorry.